My people, welcome to another video lesson. What a great day to be alive, no matter where you are, no matter what you're doing. I'm happy that you're here with me, and we're going to go ahead and jump right in. So today's lesson, we're going to cover section 8.6 in our textbook, Solving Rational Equations and Inequalities. And for this video, we're going to just look at equations. I'll do another video that deals with inequalities that you can watch separately. Okay, so if you don't have the paper that I have in front of you, if you don't have this downloaded yet, what I'd like you to do is stop what you're doing now and either download this from the remind message that I sent you, or you can go to my webpage through the Stratford homepage and you can download this. There's a link to this on my website. Just find my name. It'll be one of the first things you see there right in the middle column. Will be an 8.6 Solving Rational Equations and Inequalities notes page. So hopefully you have this printed because we're going to jump right in and do this together. Okay. So when we solve equations, you can use the following 3 steps to solve all rational equations. I'm pretty comfortable to tell you that I've kind of narrowed this down or simplified this to 3 different equations, or 3 different steps to solve really any equation that you're going to have. Okay, so basically, just to give us some background, if I covered up this equals 3 over x plus 3, what you'd have there is that's basically a addition or subtraction problem that we've been doing the first part of chapter 8. So you can handle that. The only thing that's changing is we're adding an equal sign and we're putting something to the right of the equal sign. We're making an equation. Okay, so here's step 1. You're going to do step 1 every single rational equation, okay, that you're going to see. And step 1 is pretty simple. You want to get 1 fraction equals 1 fraction. So if you look at the original equation that you're given, the right-hand side is already 1 fraction, so there's no work that we need to do there. The left-hand side is where we have to do quite a bit of work. Okay, now I've tried to get you to pound this idea into your head, but anytime in chapter 8 that you see quadratic trinomials, the first thing ever I want you to try to do is see if you can factor it. Okay, so that's the first thing I'm going to do. I'm going to just try rewriting this. So I have 2x over x plus 5 minus, now x squared minus x minus 10, there's nothing that I know of that multiplies to negative 10 and adds up to negative 1. So that actually is good. We don't need to factor that. So we have x squared minus x minus 10 all over. Now x squared plus 8x plus 15, that does factor. 2 numbers that multiply to 15 that add up to positive 8, that's x plus 5 times x plus 3 equals 3 over x plus 3. Now again, our goal in step 1 is to get 1 fraction equals 1 fraction. So what we want to do here is we want to look at the left-hand side, forgot a parenthesis, and then what we want to do is we want to try to identify how can we get those 2 fractions together. Well, you know how to do this. You got to find your least common denominator. Okay, you got to find your least common denominator, and then you're going to go from there. So as we see here, I've got an x plus 5 and an x plus 5 in both denominators. So what I'm going to use for my least common denominator is I'm going to use x plus 5 times x plus 3. So as I look at this first fraction, the only thing that the denominator here is missing is this x plus 3. So I'm going to multiply the numerator, 2x, I'm going to multiply that by x plus 3. Minus, this denominator is actually good. I don't need to multiply the second fraction by anything. So what I have here is I have x squared minus x minus 10 equals 3 over x plus 3. Now some of you might be asking, why did I put the second trinomial in parentheses? And the reason that I did that is, since I'm subtracting this trinomial, by putting that in the parentheses, it reminds me that I have to actually subtract each one of these 3 terms. In other words, I have to distribute the negative sign. If you just wrote minus x squared minus x minus 10 without any parentheses, my fear is that you would forget that you're actually subtracting all 3 of these terms, and you would just say that you were simply subtracting the first term. Okay, so it's a good idea to put that in parentheses to help you remember that you need to distribute. Okay, so then what I want to do, now that I've got 1 fraction, I'm going to clean this up a little bit. Okay, so I have 2x squared plus 6x minus x squared minus x minus 10 all over. This one's running out of ink. X plus 5. It's because I grade in red. So this one gets used quite a bit more than the others. Okay. we still have equals 3 over x plus 3, but I'll fill that in here in a minute. Okay, so then what we're going to do is we're going to go ahead and we're going to clean up our numerator here. So I have 2x squared minus x squared, so that's just x squared. Plus 6x minus x is plus 5x. And, oh, you know what I did? I did the same thing that I told you not to do. I forgot to distribute the negative. Okay, so this should be plus x. It should be plus 10. I wish I did that on purpose to just make sure you're paying attention. But my people, I just made a mistake. Okay, I just made a mistake. So instead of plus 5x, I'm going to cross this off. See, even the great ones make mistakes, my people. X squared plus 7x, okay? And then we've got plus 10, okay, plus 10. All over x plus 5 times x plus 3 equals 3 over x plus 3. Okay, so now we've effectively got one fraction equals one fraction. So once you get one fraction equals one fraction, you can move on to your second step. Second step is cross multiply and solve for x. Okay, cross multiply and solve for x. Now just a minute ago I reminded you, anytime you see a quadratic trinomial, okay, you want to see if it can factor. Okay, so I'm looking for two numbers that multiply to give me 10 that add up to give me 7. Okay, if you think, it shouldn't take you too long to get 5 and 2 on that. So when I write it out, I'm going to go ahead and factor it. So that's going to be x plus 5 times x plus 2 all over x plus 5 times x plus 3 equals 3 over x plus 3. Okay? Now you could, if you wanted to, cross multiply from here, but I would tell you that you're going to make your life a little bit easier if you notice in your numerator and denominator you have an x plus 5 and an x plus 5. Okay? So we cancel those out. It makes the multiplication a little bit easier for us. So then I'm going to go ahead and cross multiply. So when I do that, I have 3 times x plus 3 equals x plus 2 times x plus 3. Okay? Well, hey, looky there. We've got something else algebraically that can cancel out. We've got an x plus 3 on both sides of the equal sign. So those can cancel out. So really, what we have here is we have 3 equals x plus 2. Subtract 2 on both sides, and very clearly we get x equals 1. Okay? The third step that's going to be really, really important for you to not skip. A lot of you all want to skip this step, but it's, like I said, it's critically important. Step 3, you want to check for extraneous solutions. Okay, there's that word again, extraneous. Remember, extraneous just means you algebraically solve an equation and get an answer that you didn't break any rules with algebra, but for some reason when you plug it back in the original equation, you get an error message. So what we want to do is we want to take our solution here, x equals 1, and we want to plug it in the original equation and make sure that everything works out. Okay, so what I'm going to do is I'm going to come all the way back up here to the original equation, and I'm going to just plug in 1 for x. So I have 2 times 1 over 1 plus 5 minus 1 squared minus 1 minus 10 all over 1 squared plus 8 times 1 plus 15 equals 3 over 1 plus 3. Now, if it were me, I'd probably be able to check this mentally by just kind of plugging this in and writing, maybe not writing down exactly everything I did, but I'm just trying to illustrate to you that you have to plug in 1 for every x. So let's clean this up. So 2 times 1 is 2, 1 plus 5 is 6, so that's 2/6 minus 1 squared is 1, 1 minus 1 is 0, 0 minus 10 is negative 10, all over 1 plus 8 is 9, plus 15 is 24, equals 3 over 4. So what I want to do here is I want to get those these two terms combined into 1, so I'm going to use a denominator of 24. So I'm going to multiply this one by 4 over 4, and I get 8 over 24 minus, here's what I'm going to do. You see how you have minus negative? I'm going to turn that into a plus 10/24, okay, equals, let's go ahead and make this denominator 24 as well. That's not going to be a problem. So multiply this one by, let's do 6 over 6. So I have 18 over 24. And very clearly I can see this is going to work out. 8/24 plus 10/24 is in fact going to equal 18/24. So that checked out just fine, which means this is a valid answer. We're ready to move on. Okay, so again, just to summarize what we've talked about here, you can basically solve all rational equations in 3 steps. Step number 1, 1 fraction equals 1 fraction. 1 fraction on one side, 1 fraction on the other. Step number 2, cross multiply and solve for x. So once you get 1 fraction equals 1 fraction, cross multiply and solve for x. Once you get your x values, you want to plug them back in the original equation to check for an extraneous solution. Okay, once you've done that, you're good to go. You're ready to move on. Okay, so what I'd like you to do is at the bottom of this notes page, there's 4 practice problems that I'd like for you to do on your own. Follow the same 3 steps for all 4 of these questions. Some of them are a little easier than what we did. Some of them are as difficult. Some of them might be even a little more difficult than what we did here, but the same 3 steps apply to all 4 of those questions. So take a second, work on those, and then we'll get you the answers to those when you get to class. You can cross-check them with my answer key and be good to go. All right, that's the first part of 8.6, solving rational equations. I'll see you later for the second part, which is solving rational inequalities. See y'all.